In this video, we are going to cover our modeling workflows. Since we have 3 different datasets for this use case, we need 3 different modeling workflows. We could combine them into one single workflow, however, it would be unwieldy and it would be difficult to edit and keep organized. So we have elected to move it into 3 different workflows. In this video, we will only cover one of the workflows, as the other 2 workflows are nearly identical. The only difference is that we load in a different dataset in the first step here. After that, we drop our rows with null values. This is an important safety check before we move into modeling. Next, we cast to a single type. We want as many of our feature columns as possible, the numeric ones specifically, to be of type double, as they work best with SparkML. The next step will be to assemble our features into a vector. This is required when we work with SparkML models. After that, we split our data into training and test datasets at an 80-20 ratio, and then we are using a random forest classifier. We are using a classification model rather than a linear regression model since we have a binary output column in this case, whether the error was human error or not. After that, we use Spark Predict to apply our model to the testing dataset, and then we use the binary classification evaluator to evaluate our model and produce the relevant test statistics. Finally, we will save our model using the SparkML model save node. This is so that we can pull it into our final workflow and combine it with the output of our other models. In the output for this workflow, the first thing we have is the feature importance. This tells us what percentage of the model was based on which of our features. In this case, we can see that our inspector experience in months was extremely important, even more important than our production line age, telling us that inspectors with greater experience are extremely valuable and important on the production line. Additionally, we have the is night shift column. This tells us that a higher percentage of errors were made while workers were on the night shift. Finally, we have our confusion matrix and we have our validation results from our model, including our model metrics. We can see that this model alone was 77% accurate. In the next step, we will take this model, in addition to the other 2 classification models that we created on our second and third datasets on defects based on materials and our sensor failures, and combine them to produce one final result. Thank you for listening.